Now this next example will give us practice using both the elimination and substitution methods. And the system is this: 2x plus 7y equals -1, and 3x minus 5y is equal to 14. So let's use the elimination method first. Now you remember the goal in the elimination method will be to make the coefficients of either the x terms or the y terms opposites of each other. Now in this case, if we wanted to make the x terms opposite of each other, we probably would make the coefficient of one x term 6 and the other -6. To eliminate the y's, we would probably make one of the coefficients 35 and the other -35. I think I'm going to decide to eliminate the x terms here. So to do that, we're going to multiply the first equation here by -3 and the second equation then by +2. So the first equation then becomes -6x minus 21y is equal to 3, and the second equation becomes 6x minus 10y is equal to 28. Now if we add the two equations, we can see the x terms will drop out, and we're left then with -31y is equal to 31, or y then will be equal to -1. So let's next find the value for x, and we'll do that by substituting the value for y back into either original equation. And I'm going to choose the first equation, so we're going to have then 2x plus 7 times -1 being equal to -1. So we have then 2x minus 7 is equal to -1. 2x is equal to 6 then, or x is equal to +3. And so we'll then express the solution as an ordered pair. And we'll write then 3, -1. Now we're next going to consider solving the system using the substitution method. And as you can probably determine by looking at the equations, this will not be a very happy prospect, because no matter which equation we choose and whichever variable we choose to solve for, it's going to involve some fractions. But not to be deterred, we can certainly do that. So I'm going to choose to solve the first equation for y to get the ball rolling here. So if we do that, we're going to have then 7y is equal to -2x minus 1, and dividing each side by 7 will end up with -2/7x minus 1/7. And what we'll do now then is substitute this expression for y in the second equation. So we will then have 3x minus 5 times the quantity -2/7x minus 1/7 then is equal to 14. So we'll have 3x continuing the process here, and if we distribute, we can see that the -5 times the -2/7x will produce then plus 10/7x, and -5 times the -1/7 will produce then 5/7, being equal to 14. Now, since I don't like fractions a great deal, and I'm sure you probably don't either, what I'm going to do next is to eliminate the fractions from the equation. And to do that, I'm going to multiply every term here by 7. So that will then produce for us 21x plus 10x plus 5 then is equal to 98. So combining terms, we'll then have 31x plus 5 is equal to 98. And then subtracting 5 from each side, we end up then with 93. And dividing each side by 31, we can see that x will be equal to 3. Now our next task then will be to find y. And what we need to do is to substitute that value for x back into actually either equation, but probably easiest would be to put it back into this equation right here where we have y isolated. So then we'll have y is equal to negative 2/7 times 3 minus 1/7. So y is equal to negative 6/7 minus 1/7, which would be negative 7/7 then, or y would be equal to negative 1. So again, the solution we can see is the ordered pair 3, negative 1. So I think you can see that of the two methods that we used here, certainly the elimination method was probably the easiest and required the less chance for error, because in the substitution method we were dealing with fractions a great deal of the time. But certainly either method is legitimate, and it's your choice about which you choose in a particular situation to solve a system.